Good afternoon to all of you and welcome to this new EGEC webinar. Today the webinar is about mid-the members. Indeed, as we mentioned for several years now, for the last 3 years, we have doubled our membership from 120 to more than 230 members since 2022. And every year we have about 30 new members. What we want is to present these to all the geothermal stakeholders. And today we have 6 distinguished members that are available to present you their entity. They will have 7 to 8 minutes plus 2 to 3 minutes for you to ask questions. We will start in 2 minutes because some people are still connecting. Okay, now we have passed the official 2 minutes delay after 2 p.m. to start this webinar. So as I mentioned, the webinar is to present 6 EGEC members that joined us recently, and we will give them the floor for a bit less than 10 minute presentation, and so also to allow you to raise some question. You have 3 possibilities to raise a question, or you raise your hand and we'll give you the floor for a short oral question. If not, you can use the chat to put your question, and please indicate to whom your question is targeted to. As you can see, we have 6 speakers, and I immediately give the floor to Quentin Barral from Accenta to hear from you what is about Accenta and what you do in vegetal business. Quentin, the floor is for you for 8 minutes.
Thank you a lot. 1 seconde. Philippe, je dois envoyer une demande pour avoir le droit de me présenter. Tu as reçu quelque chose? Ah, voilà, c'est bon. Here we go. Thanks a lot, Philippe. Thanks a lot to the EGEC for allowing us to present our new members to all the members. So I'm starting with Accenta. All the startup we will pass 10 years old this year. And I joined Accenta 4 years ago. I'm the geoscience expert for the company. Our company is working in the in the shallow geothermal energy, just to so that everybody here know about geothermal energy. Accenta is on the shallow business, few meters to 300 meters, either on closed loop borehole exchanger or on groundwater, but our concern is delivering heat and cold to buildings, to individual buildings. Big buildings. I will have some example. I will present some example at the end of the presentation. Our driver from the beginning, 10 years ago, was that geothermal energy, geothermal heat pumps are the best way to provide heat and cold efficiency for the building, but it's very expensive. And that's why in France, for example, where we work today, geothermal energy represent 2 to 3% of the energy shares in the building, and so it has to be used as most efficient possible, not just in terms of energy, but also in terms of economy. To do so, we transform the heat exchanger that has mostly used as a heat extractor from the underground to a thermal battery and managing to produce or capture or whatever renewable energy, either from industrial source close to the building or to solar panel, either PV or thermal, and store the energy in the ground, in the heat exchanger, and then produce for the building when it's needed, the heat or the cold, or both, for the comfort, for the domestic hot water, for the process, if it's an industrial site. And it's produced mainly on thermodynamics, air, water, heat pumps, water, heat pumps, also sometimes with gas if needed for the economy. But here it is, it's we speak about we present it as a hybridation of the production, multi-source of energy, multi-source of production also. And in order to be able to sell it and to implement it, we process all the phases from the design, from the first assessment to the feasibility, the design of this complex hybrid but complex system, and then implement it. And we work as a EPC engineering, procurement, and construction company, providing to our clients all they need to have a heat and cold produced in their building, and then operating the systems because they are complex or hybrid. They have to be. We need to have a chief for this orchestra, and that's what our software does in the boiling room, in the technical room, with heat pumps and with the several systems. Very quickly about drilling, because it's our subject for all of us in the EGEC, but so that everybody has the same level of comprehension. We are mostly our system are mostly based on Barral exchanger because it's more scalable. It's more industrialable. That's our belief, and it's nothing that is new in this exchanger that we do. It's very classical in the French market, at least. W probes. Very happy to look forward about the Separatus performance just after. Where we have developed more engineering, it's in the technical room, where we developed, we're still developing a system that can be standardized and industrialized. So here you see two water heat pumps. You see a water tank, you see heat exchanger and circulating pumps, very standard for a geothermal energy system. What is not standard and what we want to standardize, it's that all the system are built in outside of the site, and they are brought and assembled in 1 week in sites. It's very, very quick to implement and build the technical room on site. So it's much more quality, much more efficacy, and less cost compared to the classical 3 to 4 months of work of coactivity in a building when it's about construction of the technical role. So just a few examples. I have 4 that I will present. Collective housing in city EGEC close to Geneva. 4,300 square meter, and in this system, it's a mix of the geothermal energy based on 17 probes, 2 geothermal heat pumps, and there are we have a gas boiler that has been kept in order to manage the very high power demand for the Monday morning when everybody goes and need to have this shower. And the balance in the underground for the thermal battery is managed with a field of thermal solar panel. Second example, this is a building, an office campus, 39,000 square meters. We replaced all the existing gas heater and classical air conditioning with 9,000 meters of Barral exchanger, cumulative length. Third one in sport campus with 2 swimming pools, one indoor, one outdoor, tennis, paddle, and all other sports indoors facilities, 5,000 square meters total. And here it's a mix of heat pumps, geothermal heat pumps, and solar panel. That brings, sorry, a typo, it's not 26 square meters, but 265, 5 is missing here. And the last one, warehouse, product storage warehouse, quite a big surface too, and that's a mix of geothermal heat pumps and aerothermal heat pumps that brings to this building heat and cold. It is for the presentation.
Thank you, Quentin. Do you have questions to Accenta? Oh, it was clear. Maybe just a remark from my side. It was really welcome. 3 days ago now, on Tuesday, the European Commission released a new initiative on citizens' energy package, where we can see and highlight that there's a need to have this kind of shallow geothermal networks, no, to answer and to help also consumers to participate to the development of a project. So really welcome new policy initiative.
Right.
At that stage, I don't see any question for you, Quentin. Maybe just one remark from my side is that on top of Accenta, you're also deeply involved in the French Geothermal Association, and you are one of the experts in eco-design regulation for heat pumps. So feel free also, all of you, to reach to Quentin if you want to know more about all regulation for heat pump and eco-design. Thank you, Quentin.
Thank you, Philippe.
And now I move to Sian from Bell Geospace. In my order, it's you to intervene and to present us one of fascinating new technology to better understand geothermal. So Sian, the floor is yours.
Thank you, and good afternoon, everybody. I'll just get the screen sharing happening now. Okay, how is that looking?
Perfect. Floor is yours.
Excellent. So good afternoon. Thank you, everyone, for your attention. Appreciate that. And in the next, I believe, 8 to 10 minutes, I'm going to be looking at geothermal development more from a subsurface perspective. So as you know, and as we are seeing, Europe is really accelerating geothermal exploration. And one of the challenges faced is site selection, and specifically mapping the large scale subsurface systems really efficiently before committing to some of the later stage exploration and more expensive techniques like seismic, for example, or drilling. So I work with Bell Geospace, and we're a company specializing in airborne full tensor gravity gradiometry surveys, and these are widely used in energy and resource exploration. So in recent years, we've been increasingly active supporting geothermal developers across Europe, and in particular in Germany, where gravity data is really helping to better understand those subsurface structures that control the geothermal systems. So who and what? Who are we? What do we do? We were established in 1994, and in the early 2000s, we pioneered airborne FTG, and this makes us the longest serving provider of airborne FTG data. Since those early days, we've conducted more than 650 surveys across the globe, acquiring over 2.3 million line kilometers of FTG data, and with an excellent unblemished safety record. So our airborne platform integrates different data types. The primary instrument and primary data type is the gravity gradiometry instrument, the FTG. And we also incorporate scalar gravity and magnetics, which allow us to map subsurface density variations, density contrast, and the structural architecture at a regional scale. So this technology has an excellent track record initially and historically in oil and gas exploration, but today we're seeing an increasing demand through the energy transition from geothermal and critical mineral exploration, where understanding regional geological structure is very important. So FTG, where is this used? What is it? Airborne is it's a very versatile geophysical technology that maps the subsurface density variations and provides a regional insight into geological structure. So for geothermal exploration in particular, this is very valuable for mapping basin architecture, major fault zones, structural controls, and potentially damage zones that influence the heat flow and reservoir development. The technologies, as we talked about, is very well proven across other sectors, including hydrocarbon and mineral exploration. And more recently, we're also seeing a real growth in geothermal and also natural hydrogen exploration. So why this particular data? What does it bring? Well, when developing geothermal projects, there are a huge number of questions to be answered, and not just in the geoscience domain, but just looking at a few of those. Where are these large-scale structural controls? What are the geological structures, and what is the density contrast linked to faulting or basin geometry? And where should our exploration techniques and where should our seismic campaign be focused? Gravity data is particularly useful in geothermal exploration because many geothermal systems are controlled by deep structural features, such as faults, basin margins, and basement highs. And airborne gravity allows us to map these structures quickly and consistently across quite large areas. So even where legacy data, for example, seismic data or even new seismic data or well data may be quite limited, we can create, by combining this with the FTG, we can create or construct a good 3D model of the subsurface, helping us to understand that basin geometry, what the major fault corridors are, the depth to basement across our area of interest. So exactly where does it fit in the process, in the exploration phase? Well, throughout the project exploration and development stages, there's a need to balance the exploration value with the budget. And airborne gravity is often introduced in the early stages, where it can rapidly map large areas and identify those regional structural trends at a very competitive cost. And as the exploration progresses, the data supports screening and evaluation and helps us to define that basin architecture and map out those fault corridors that may control the permeability and the fluid flow, helping us to prioritize the most prospective areas before moving on to other techniques, on-the-ground techniques such as seismic surveys and drilling. And not forgetting the other challenges that are associated with geothermal projects. One of the realities is that the majority of these projects are going to be located close to towns, infrastructure, in densely populated areas. So that's going to create more challenges for traditional ground-based exploration methods. So seismic acquisition, ground gravity, other surface techniques, they can face permitting constraints, environmental restrictions, etc., access issues, and of course, community concerns. Airborne full tensor gravity gradiometry, it offers a very useful alternative in these situations because the survey's flown from an aircraft. It's completely non-invasive and it requires no ground equipment, no line clearing, and somewhat easier permitting to get the go-ahead for a project. So in effect, the aircraft simply flies above the area, measuring tiny variations in the Earth's gravitational field, allowing us to map those basin structures and fault systems without disrupting any activity on the ground. So for geothermal projects in populated areas or in areas where there may be environmentally sensitive zones or sensitive agriculture going on, that ability to collect high quality data, to understand the subsurface and to do that quickly and unobtrusively is a real advantage. So to give you a little snapshot of where we've been working recently, as you can see here, Germany, it's really become for us one of the most active geothermal markets in Europe. And we've already supported several developers there. This is a little snapshot of some of those who have kindly given us permission to mention these projects. So our surveys here have been used to help, again, to define that subsurface structure, fault systems associated with these geothermal plays. The data sets are typically integrated with other available geophysics, such as seismic, magnetics, and existing well information. Projects have been initiated by local municipalities, private companies, and also by partnerships between commercial companies and local government partnerships. So as you see there, we have a couple of ongoing projects, one with Vulcan and one with Lithium de France. And these have dual purposes. Those are geothermal energy and lithium brine extraction. So, yep, this is where we're working or have been working in Europe. So this is our footprint where we've acquired over 130,000 kilometers of airborne FTG. Whilst we do operate globally, Europe has been an increasingly active region for us. So we're working here with for example, geological surveys, including in Sweden and in Finland, and other companies who are exploring for critical minerals that are essential for energy transition, as well as the geothermal projects that I mentioned on our last slide. So yes, I'm not going to read these out. These are just some comments from geothermal clients that we have worked with or are working with. The most important takeaway from this really is the emphasis on how useful airborne FTG can be in that early exploration program, particularly when covering large areas and wanting to get this done quickly to gain an understanding of the subsurface and understand the regional geological model. And that understanding can then help to guide where the next steps should be focused. So yes, as geothermal continues to grow, and it's exciting to see that happen, that airborne gravity can play a really crucial role in improving regional subsurface understanding and helping to reduce that early stage risk and attract the investment that's needed. So if any of what I've covered very quickly is relevant to your work, we'd be really happy to sort of continue a conversation with you, whether that's sharing ideas or collaborating or discussing existing or potential projects. We've got a few of our members, our colleagues shown here. There's Colm, Arne, and myself. So yeah, please feel free to get in touch.
Thank you, Sian. Really interesting indeed to see these new technologies helping geothermal to be better understood before drilling and indeed to decrease also the risk associated with the first drilling. Do we have some question to Sian? Of course, also you as a panelist, and you can ask a question to Bell Geospace. I don't see any question, but I have a question myself. So indeed, what I understand from the comment from Vulcan is that you may operate in a business model prior to a more developed 3D seismic exploration campaign, no? So at the end, we can understand that your role would be to better size, no? The perimeter, no, of the exploration campaign. Is it something that you are in your model is that, or you plan a larger role in the exploration phase?
I'm sorry, could you repeat the question?
I see from the comment from Vulcan
Oh, yes.
Energy, they were saying that they use your tool prior to do a 3D seismic exploration campaign. No?
Yes, and that's quite a common approach, is to use the FTG data to get a good regional understanding of the subsurface, and from that initial mapping of the geological structure to identify areas of interest where which would benefit from other geophysical techniques such as the seismic, and in doing so you can prioritize those areas, limit their size to just focus on where that geological complexity lies, and avoid overspending your budget on those areas.
It's a good point, and I see that from the audience we have a question to you. Also, you mentioned that you have a global footprint, but in geothermal, you just show activities in Europe. So does Bell Geospace do similar geothermal studies in the USA?
We operate in the USA. As far as I'm aware, we have not yet flown for a geothermal project in the USA, but we certainly fly projects there for mineral exploration, as well as historically oil and gas. Yes, so being airborne has the advantage that we can mobilize pretty much anywhere in the world.
Thank you, Sian. If you wish to liaise with Sian, we have contact detail, and thank you again for your intervention today. I move on now, because indeed the objective of this member is to have a short presentation and to have some helicopter overview. And the next one now is Niyazi, Professor Dr. Niyazi Aksoy, a good friend, so it's why I said Niyazi. good to see you again and with your new activities, the NTU Geothermal. So please tell us a bit more.
Thank you, Philippe. Yeah, I think you can see my screen.
I confirm, floor is yours.
Yeah. Thank you again for having me today. First of all, I would like to welcome everyone. I am here today to introduce my company, NTU Geothermal Consultancy Limited. I am one of the founders of NTU Geothermal Consultancy. I started my career in the field as a drilling engineer and later specialized in well testing and reservoir engineering. After many years of practical industry experience, I moved into academia where I taught these subjects. Today, together with my colleagues at NTU Geothermal Consultancy, we combine our multidisciplinary expertise to support the sustainable growth of the geothermal sector. NTU Geothermal Consultancy is based in Izmir, Turkey. Izmir is central to Turkey's geothermal energy landscape. In fact, if you look within a 200-kilometer range of Izmir, you will find geothermal power plants generating a total of almost 1,800 megawatts. We had the privilege of serving numerous reputable local and international companies. We are proud to provide engineering and consulting services for geothermal power plants with a combined installed capacity of approximately 600 megawatts, along with the greenhouse applications and district heating networks. NTU Geothermal Consultancy offers expert services in geoscience with particular focus on drilling, well testing, geochemistry, geothermal field management, including reservoir engineering and 3D reservoir modeling. With your permission, I would like to present 3 key completed projects that clearly demonstrate NTU Consultancy capability and its expertise. The first project, I would like to draw your attention to the Salavatlı geothermal field in Turkey, which we consider a perfect example of both horizontal and vertical growth. DORA 1 is a landmark project for both NTU and the industry in Turkey. It was commissioned in 2006 with an installed capacity of nearly 8 megawatts. It's the first private geothermal power plant in Turkey and was developed by MB Holding. Today, Turkey's installed geothermal power capacity has reached around 1,800 megawatts. DORA 1 was the first building block of that journey. What makes this project special is its step-by-step growth. By carefully monitoring on the reservoir over time, we were able to expand 68.4 megawatts in total. On the slide, you can see the development of the power plants and commissioning dates. Now, the total power plant power is reached 68.4 megawatts. Another 25 megawatt unit is expected to be online by 2027. As you can see on the slide, this project combines power generation, greenhouse heating, and commercial CO2 production, turning the geothermal field into a multi-purpose energy hub. The second example is the Velika geothermal power plant in Croatia, also an investment by MB Holding. For the geothermal industry, the use of depleted oil wells has long been a dream. What makes this project truly unique is that offers a concrete real-world example of this concept through the utilization of abandoned oil wells. On the left side of the slide, you can see one of the selected wells together with its Christmas tree with traces of crude oil still visible around it. NTU Geothermal Consultancy was responsible for well selection, deepening, perforation, production, and injection testing, as well as the evaluation of wells capacities. The photos show the workover rig, the well testing phase, and the operational power plant. As a result, the 16 megawatts Velika geothermal power plant commissioned in 2018. Not only is Velika geothermal power plant the first geothermal power plant in Croatia and Balkans, but also it proved that the Pannonian Basin is one of the world's most important geothermal areas with a potential of thousands megawatts. In this slide features the founders of NTU Geothermal Consultancy, identified by their initials, together with the late Muharrem Balat, the owner of the MB Holding. In the background, the abandoned wells selected for the project are visible. These are later successfully converted into geothermal production and reinjection wells. This photograph was taken in 2014. Mr. Balat passed away 3 years ago. He was a visionary investor. He made significant contributions on geothermal energy, both in Turkey and Croatia. On the third example of NTU studies, we focus on the environment. Non-condensable gases, or NCG, produced together with geothermal fluids are mainly greenhouse gases, represent one of the key challenges in geothermal development. At NTU, we implemented a project to dissolve these gases into reinjection fluid and return them back to the reservoir. This is one of the most cost-effective ways to protect environment, support sustainable production, and help mitigate climate change. The picture shows the compressor of an NCG injection facility in Turkey, where NTU provided consultancy and engineering services for Tanko Energy. Finally, that concludes my presentation. Thank you very much for your interest.
Thank you, Niyazi. Really interesting. I look at if there's a question to you, not at that stage. So we understand that you're a consultancy company based in Turkey, but you operate all over the world. You mentioned project that you did in Turkey, Indonesia, Philippines. You are still looking at this market, or you focus more in Turkey because we see now a new wave of power plants in Turkey?
Yeah, we have studying on many projects in Turkey, but some economical crisis exist in Turkey, so the geothermal projects are a bit slowed down, but at least 100 megawatts power plant still under construction in Turkey now. We are also studying in Croatia. Another Turkish company, Soyak Energy, try to improve a geothermal power plant in Croatia, but as you know, some bureaucratic problems still getting slow our projects in there.
No, indeed, we are following that, but it seems that 2026 could be a good year for project in Croatia with hopefully a tariff to help investors and developers to do their projects.
I hope, yeah.
Thank you, Niyazi. I know it's time to give the floor to the next one, but I see that Sian, you would like to answer live on the question asked by our member, François Humbert from the Royal Meteorological Institute of Belgium. So, Sian, I give you back the floor for 1 minute answer.
Yes, I just wanted to say that you asked about publications regarding the recent projects that we've flown in Germany. At the moment, those projects are ongoing, those geothermal development projects. And so there haven't been any released publications related to the data that we've flown, etc. I can give you some links to publications on the FTG technology and how to interpret the data, etc., which are more general. But at this stage, those projects are, I guess, still in a confidential state. So nothing published at this point.
Thank you, Sian. And on all this topic, just for information, we are planning a webinar, maybe April, May, on all the different exploration activities, including the use of AI in exploration. We have a lot of data treatment to do. But that it's another topic, because now it's the time to give the floor to Oliver Buschor from Separatus from Switzerland, and we now give you the floor for 8 to 10 minute presentation to know better about your activities. Oliver, the floor is yours.
Hello, thank you for this opportunity to present our company. So we are from Separatus. We call it a simple smart system. And because we do shallow geothermal energy to be in the area, and we see especially in the renovation market, why do people decide against the geothermal energy? It's mostly due to the high investment costs, total damaged garden because of the big drilling rigs, or that there are just not enough space to drill at all. We have then developed the Separatus system, a solution with a modular, slim geothermal system where we have a split pipe technology. So we combine flow and return in the same pipe, separated by a thin wall in the middle, to realize geothermal energy for less costs, with less damage, and with less space needed for the realization. So I will give you a short introduction about our system. What we have at the moment is a geothermal vertical heat exchanger, like a borehole loop with a standard connection in either 25, 32 or 40 millimeters at the top. So we have the borehole loop. We have a little connector which is allowing to connect the flow to the chambers of the flow and the return with the head correctly, and then everything is welded with an electrofusion fitting. So the probe is Swiss made, and we are certified by SKZ already. We also developed the second generation of our products. We just published them last month's Geotherm in Offenburg. So we have a T-piece for the serial connection of multiple probes. We have a 90-degree angle to use the split pipe as well for the connection line. And we also have a splitter to connect two probes in parallel. On the long term, we also want to develop the manifold chamber with the split pipe technology. So you don't only have one manifold chamber for the distribution and for the collection. So the Separatus system, to say it in a few words, is like we have a foolproof connection technology. You cannot connect them in a wrong way. It's quick and easy to install, and we developed especially a probe for short boreholes up to 130 meters, which is ideal for regeneration, but also if you have any depth restrictions. Exactly, the pipe itself is PN10, so it's also a bit limiting the depth. So what we see is that we have an ideal solution for geothermal energy, for example, for terrace houses, but there are so many to be renovated, or where the heating system has to be changed. But there is no space for big drilling rigs, and with air source heat pump you also get some problems because of the noise towards the neighbor, so it's very difficult area. We also have the possibility with our borehole loop to energetic activate structural components in the areas of for example of foundations or underpinning, anchorage or soil nailing. Our probe has a diameter of only 51 millimeters, so it fits in very small components, and it can be hydraulic connected in series very easily. So we started this cooperation with EGEC Titan, one of the well-known producer of micropiles. Here you can see an example of a micropile which is self-drilled and backfilled with cement, and you can then just install the Separatus probe into the inner part of the pile, which has usually so far no real usability. But you can also install Separatus in standard energy piles, where you just attach them to the reinforcement cage, and then there is no time-consuming threading or bending of the pipe, and also a minimum bending where the radius is not required. So I want to share with you the benefits of our system. So the biggest benefit is that you can reduce the drilling diameter. With Separatus, you can drill with 100 millimeters and still can install the probe easily and comfortable. If you compare it with a standard system, W32, it's often drilled with 152 millimeters, so it's much bigger. And then the big advantage is that you can use a small drilling rig. I compare it here concerning the weight. So you can use a drilling rig with 3.6 tons, which is the equivalent of one elephant. In the standard, what we see today, you really install a lot of borehole loops with like big drilling rigs, 15 to 16 tons. It's the equivalent of 4.5 elephants. But also the size of the rig itself is very important if you want to increase the visibility in narrow spaces. So on the left you can see the small drilling rig specifically used for Separatus can have a width of up to 1 meter, so it's very small. You can get into the gardens. On the other hand, you have the big drilling rig with almost 2 meters width. You do not get into the garden easily, and you make a lot of damage once you're there. And then if you compare backfilling material for 100-meter borehole depth. So with Separatus and 100 millimeters, you use about 0.6 cubic meters. With 152 millimeters, it's almost 3 times more, so it's 1.5 cubic meters. So that's real money you put into the borehole for only a little effect. Then I want to show some references with you as well. So we started the company in 2023, so we are still a small company startup. We did the first test projects and in 2024, and now we are in the market with the EGEC certifications since 2025, but we were already able to do realizations in Switzerland, in Belgium, in the Netherlands, in Germany, in Austria, in Czech Republic. Most recently in February, we did the first installation there. We will have the first installation in Spain in the summer of 2026, and we are really looking for the first projects in the UK as well as in France. And if you know somebody or if you are the one who is ready for this innovation, just get in contact with us. I want to show the examples, for example, here from Belgium, where we have the Drill Geothermy. It's our drilling partner. They're specialized for geothermal energy in urban spaces. So they have small drilling rigs. Everything on the construction site is engineered to the end to drill small diameters as well. So they do think about geothermal energy, and they also can realize where everybody else is going to think it's not possible at this place. We have realization shown here, for example, in Germany, in Wangen, in Allgäu. It's in the very southern part. The drilling was done by Baugrund Süd. We have references in Switzerland. Here an example from Davos. It's almost 2,000 meters above the sea level. We found, so the driller found artesian water, so he couldn't drill to 200 meters as he wanted to do in the beginning. Then he switched to Separatus, and we realized 30 boreholes with 40 meters depth, and each 3 boreholes were connected in series. We also did realizations in Austria, where we could replace the heating system for a very old building, and it works very good at the moment. In the Netherlands, we were able to activate energy piles. So the piles were needed for the foundation of the building, and we were then able to deliver the probes for the geothermal activation of the piles. So yes, we are from Separatus. We are a young company, and we always think win-win, and we are actively looking for global collaboration partnerships. So thank you for the time, and if there are any questions, reach out to me.
Thank you, Oliver. Really clear and really nice to see all this innovation and startup in geothermal. I don't know if there's some question. Me, I have a question. Is that so? You're a Swiss company. You manufacture everything in Switzerland. So showing again Switzerland as a champion in equipment manufacturing for shallow geothermal. How do you plan your next development in the business model? So your manufacturers, developers, installers, operators.
We are we have outsourced the manufacturing to our partner who is extruding the pipe, and then we have a partner in Germany who builds he's the partner but also an investor in the company who builds the head and all the tools we are needing. And then from our side with Separatus, we mostly want to sell our probes to drillers or to investors in the development of the buildings, but we also want to go new ways and do the marketing for geothermal energy directly to end customers. So we see that there is not much done in this area. We see a lot of marketing for end customers for air source heat pump, but not for geothermal heat pumps. So we really want to go and get in contact with the end customers, and for them then also realize projects where we then manage everything from the drilling, from the heat pump installations, but also from the selection of the correct borehole loop.
Thank you. Do we have any questions to Oliver? No? Maybe just a last question from myself. You say end users. What is the maximum capacity you can have with such a borehole?
So with our rope, you can go up to 130 meters, and in watts per meter, it's always difficult to say because it's very depending on the soil. But what we see in 3 different test sites, where we're comparing Separatus with W32 directly, we can see that we receive the same power and the same temperatures as in W32.
Okay, that's clear. Thank you very much, Oliver. And from
Thank you.
Switzerland, we fly to Netherlands and we give the floor to Bas to hear more about the topic not yet today is geothermal storage. Bas, the floor is yours.
Thank you very much, Philippe, and also EGEC for giving this opportunity to present more about my company, DTESS. I would like to tell you more about geothermal heating, cooling, and also storage. First, I would introduce myself. I studied geochemistry, and then I started to work at a soil remediation company where we used innovative technologies for soil remediation, and that's also interesting to combine with geothermal solutions. But after that period, I worked already 18 years in the shallow and deep geothermal market with a special focus on the ETESS technology, closed loop systems, surface water, and during the last 10 years, also focusing on high temperature and middle range ETESS projects. And my focus is always to look for international projects. I've worked for IF Technology, which is mainly focusing on the Dutch market. And therefore, I started my company DTESS in 2024 to work on the distribution of ETESS technologies to other countries. Now, who is DTESS? It's Dutch Thermal Energy Storage Solutions. So we are a Dutch-based company, but we do projects in other countries like in Belgium, in Japan, Korea, the US, UK, other countries in Europe, but also in Ukraine. And the focus is still on the shallow and deep geothermal projects, especially on ETESS technologies. And what we do is we provide project management, business development, and knowledge exchange. I will dive in more detail later in this presentation. Now, what are the major technologies we cover? First, the closed loop systems. I think there are already some presentations today which presented the closed loop technology to harvest heat and cold for heating and cooling buildings. But we are more focused on the ETESS technology, aquifer thermal energy storage, which has benefits compared to BTESS, especially that with a smaller number of wells, you can provide higher capacities. But on the other hand, you still depend on aquifers, and the advantage of BTESS is that you can apply it nearly everywhere. To balance the ETESS system, we also use the technology to use surface water energy, because in winter, surface water bodies are quite cold. So you can harvest the cold, store it in your aquifer, and then reuse it in the summertime as cooling source. And the same in summertime, you can harvest the heat and store it and then reuse it in wintertime as a heating source. The high temperature ETESS is a kind of add-on on the ETESS technology. ETESS, I will explain in more detail, is especially focused on heating and cooling, and high temperature or middle range ETESS systems are especially focused on heat storage in a district heating network. And then the source could be deep geothermal. So I have some experience with deep geothermal, but my primary focus is on the ETESS, surface water, and high temperature ETESS. Now let's dive a little bit more in the ETESS technology itself. It's a very nice technology for heating and cooling buildings. But you have to think that this is the best performance is when it works as a battery of heat and cold. So during winter time, you take out the cold from the building, you store it in the cold well, and then during the summertime, you abstract the cold water, use it for cooling down the building, and then the heat of the building will be stored in the warm well, and then in wintertime, you use the warm water to heat up the building. Normally, we operate the cold wells with temperatures around 5 to 10 degrees. And the advantage is of that temperature level is that you can use it directly for cooling your building, which gives you a very high COP. In the heating mode, the warm well is often between 13 to 17 degrees. And when you heat up the building, you need a heat pump to increase the temperature level to 40, 50 degrees for heating the buildings. A requirement of this technology is that you, of course, need aquifers. That could be sand aquifers, but in some cases, like in the UK, we have worked with limestone or with sandstone formations. Typical flow rates are between 25 to 250 cubes per hour, which generates a capacity of 250 to 2 megawatt cooling or heating capacity per doublet system. And a doublet is one warm well and one cold well. Now, as mentioned in the cooling mode, because we can have a direct cooling of the building, you have a very high COP, a coefficient of performance. So with one piece of electricity, you generate 30 to 40 pieces of cold. And compared to air conditioning, the COP is 3. So one piece of electricity is 3 pieces of cold. So you can see that is a very efficient technology. In the heating mode, you always need a heat pump, which limits the COP to 4 to 5. The advantage is that this is one unit, but if you need more, you can multiply the number of doublets, so you can increase your capacity and tune it, and design it according to the wishes and demands of the building. Now, where is this technology applied? Especially in office buildings, because office buildings often need heating and cooling, so that's a very good combination. Nearly all Dutch hospitals has the DTESS technology. We see it's in university campuses, also in greenhouses, airports, shopping centers, residential areas, and also data centers is an upcoming market. Then they use the DTESS system to store cold and then reuse it for cooling the data centers itself. The new step is that we not only use the DTESS system for heating and cooling, but that we use it as a heat storage medium, large-scale heat storage. And then you can use it in the middle range temperature. It's between 30 to 50 degrees, and you can have it in a high temperature DTESS system with temperatures between 50 to 125 degrees. And the idea is that in summertime, there's often a surplus of heat, or there's still production of geothermal heat or solar panel or collectors which are producing heat, but you don't need the heat at that moment. So when you store it in your DTESS system, you can reuse it during winter time when there is additional need for heat. Why do we have these two temperature levels? Middle range 50 is that you can apply it with common materials. When you go higher, you need more advanced and temperature resistant materials. Now, why I'm working on these technologies? Because I'm really motivated to bring this technology abroad. And when you see in the Netherlands, about 40 years ago, we started with the first systems, and then during the years, we see an increase of the DTESS systems in the Netherlands. And at the moment, we have around more than 4,000 systems. But when I look around in the rest of the world, and this is published by a German PhD student, then I see that in the Netherlands there are many systems, but in the rest of the world we just see a very small number of DTESS systems. And that was my strong motivation to say, okay, how can we spread the knowledge, technology, experience of ETESS in the world? Because I believe it's still sustainable and reliable technology, but due to a lack of knowledge, experience, it's not so applied in many other countries. So is it possible in other countries? I think yes, especially in the green areas. And also good to know that these green areas are all often kind of deltas, areas where also the big cities are present. So I believe that this technology can be adopted in many more countries. Now, what is my specific role in this? I think I have three pillars of my company. First, I would like to help initiatives from idea to realization by doing feasibility study, design, permitting, also supervision. And what we also do is to help in the cost reduction in other projects. The second one is that we do not set up our own companies in all kind of countries, but what we do is that we support other companies in other countries to develop the ETESS business by themselves. Like in Japan, they want to build on this business, but we can help them to say, okay, how is the value chain? What are the relevant stakeholders? What are the critical success factors? How can you work on it to make it a success in your own country? Now, that's something we can do by sharing knowledge, giving trainings, courses, organize trips, fact-finding missions to the country or to the Netherlands to see and observe. Last slide is where are our project at the moment. I think it's interesting to mention that we are now participating in a Horizon Europe program, Uses for Heat, where we demonstrate a middle-range ETESS system in the Netherlands. And we hope to publish in the next 2 years more about this information. I also participate in an EIA TCP energy storage task 45, where we develop knowledge about large-scale heat storage. It's not only ETESS, but also BTESS, TTESS, and PTESS. I work on Ukraine projects to see how we can support the rebuild of this country and see how we can make them less dependent on Russian gas and give them their own energy infrastructure. I work in Japan and other countries. US is now very interested in data centers. So that's what I can also offer to others. If you need more help, support on ETESS, I'm very welcome to help you. Thank you very much.
Thank you, Bas. Really interesting. I think that time is running. I will leave the time for people to ask you some questions. In any case, I have some questions to you, but now let's give the floor to Michel from SEA to finish the presentation, and after we still have some time for a Q&A. So Michel, I give you the floor. Tell us a bit more what is happening in Geneva.
Hello everyone. Thank you for the invitation. I'm going to share my screen. I hope you see it.
I confirm.
So my name is Michel Meyer. I'm head of thermal and geothermal solution at SIG. SIG means Service Industriel de Genève, the industrial services of Geneva. It's a utility, a public company owned by the canton of Geneva and Geneva municipalities. And actually, as many utilities in Switzerland, we are linked to many activities. For instance, water supply, drinkable water supply, natural gas supply, energy efficiency, electricity production and distribution with different type of producers, hydraulic, wind power, solar plants. We're also working on networks and optic fibers, on waste management, on water treatment, wastewater, and of course in the sector of thermal energy, which is quite new for us and strong development today. The company is working in Geneva, more than 1,700 employees with a turnover of more than 1 billion Swiss francs per year. So it means that we do have a lot of actives, but these assets are only on the Swiss territory, on the Geneva territory, which is a very small territory, approximately 300 square kilometers, where we do have some dams, some waste management plants, waste incineration plants, some pumping station for water supply or for district cooling supply, some solar plants, water treatment plants, and we even piloting the exploitation of the jet d'eau, the water fountain, well known in Geneva, so active in many fields. But together with the canton of Geneva, approximately 10 years ago, a bit more than 10 years ago, we launched a program of development of geothermal energy, the name of which is Geosciences. This program aims to go to a strong and sustainable implementation of geothermal use in Geneva. We are trying to develop all type of geothermal energy, shallow closed loop system, but also shallow open loop systems. And now we are focusing on deeper targets, medium depth geothermal systems. And in this program, of course, we were working a lot on resources appraisal, geological exploration, but not only, we also worked on several different aspects, the legal framework, the regional coordination, data management, communication, and so on, just to try to develop a good framework for the development of geothermal energy. And today I will focus a bit more on what happened on the medium depth geothermal systems, because as everywhere in Switzerland, we don't have any oil and gas traditions. So it means that we had to begin from scratch. The deeper underground is not known in Switzerland. And in the beginning, we launched some 2D lines, 2D seismic lines that allowed us to drill 2 first wells. Deeper well, not so deep for some of you, but 700 meter deep for the first one, 1.5 kilometer for the second one. The first well was very productive, highly productive, high flow rate. That's an artesian flow rate. And the picture that you see there is without any pump. It's the 10 bars of pressure that we have in the reservoir. And this well was really important for us because it showed us that if we drill at the right place, we could have some good flow rate. The first well was done, that was an exploration well in a completely different geological context. And we learned a lot from this well, a lot of geological surprises. We learned some aspects that were not known of the underground of Geneva, but there the flow rate was really low. And it decided us to launch a huge 3D survey that was done at the end of 2021, 2022. This 3D survey was covering the whole territory of the canton of Geneva, nearly the whole territory, but mainly on the urban surface. So that was a great issue for us to launch this survey. But we got a lot of very interesting information from this survey. And now we are working on the targets we found from this survey. And actually, why we did as much on the medium depth geothermal system is because we do have some district heating and cooling networks today in Geneva. And this map shows you the situation today, not exactly today, but 2-3 years ago. And in red, you have the major district heating in Geneva. In blue, that's the main district cooling system, mainly fed by water from the lake. And this district heating today is mainly fed by waste incinerator that you have here in purple. It shows you the exploitation of the network during 1 year. And you see in purple the amount of energy that is delivered with the help of this waste incinerator. And in black, you have the other supply we are using, which is gas today. And that's the situation of today, but it's under strong development because the population of Geneva voted in order to ask us, the public company, to have a strong development in district heating and district cooling in Geneva. And it means that we have to double the size of this network during the next 10 to 15 years. And in orange, you have the extension of the district heating that will be done, that is under construction. Actually, there are many building sites everywhere in Geneva. And in light blue, you have the extension of the district cooling system. Actually, it's a district cooling system because it's mainly fed by water from the lake, but it's also producing heat with large heat pump. And the major issue is that we not only have to develop this district heating, but we are engaged to have at least 80% of non-fossil energy in this district heating by 2030. So in the meantime, we are developing the networks, but also working on several new production facilities based on new renewable. And these facilities, the major facilities are related to lake water heat pump, some sewage water heat pump. So it means water linked to water treatment plants. But we are also working on some recovery of it from data center, wood boilers, waste wood boilers. And the question 2-3 years ago was, what is it possible to integrate, to use also some deeper or medium depth geothermal facilities in the system? And of course, with the 3D we launched 3 years ago, it shows that it seems to be feasible. So I show you this slide, a kind of animation. That's the same picture I showed you before, that the situation today of the network during 1 year. You see the power that is delivered in the network, and in purple you have the waste heat, the waste issues from waste incineration, and in black the waste linked to gas supply. And actually, I will press the button and you will see an animation that will show you the extension of the network during the next 15, 20 years. And you will see some new colors appearing on the animation, which are connected to the new producing facilities that will be installed. So I press the button and you see years after year, the increasing of the size of the network. And what you have in blue is connected to the large heat pumps that will be linked to water from the lake and sewage water. And what you have in orange are the geothermal facilities that we plan to implement in the systems. So it means that we presume that we could drill 6 to 10 doublets in order to feed this network. And that's quite ambitious, but today we have good targets that have been found regarding to the 3D acquisition. And well, that's not the end of the story, because we also would like to decrease the gas content, the gas consumption. So we are working and engaged to work on seasonal heat storage solution. And together with the canton, we are also working on some building retrofitting programs in order to decrease the heat consumption and to be as soon as possible 100% renewable in our network. So it will take time, but it has been launched today. And that's what I wanted to show to you. And thank you for your attention. And I'm open to questions if you need.
Thank you, Michel. Glad to see development in Geneva is progressing step by step, drillings, exploration, and hopefully soon production. And glad also to mention storage, because it was to connect also with what Bas was saying before. Let's see if we have questions. I see that was Quentin, a question to you that we did not answer yet. Or you answer it in the written mode. Indeed, it was a question to Accenta about drilling, and you answer that you buy on the market the drilling. So that is answered. Yeah, there's some remarks more than question from Christopher. Bas, me, I have a question to you, because you didn't receive any question. Storage, what do you see the next advancement in the technology? We could say that it's quite a mature technology regarding buildings, no? office buildings. If we want to go to industry applications, no, higher temperature, larger scale, what are for you the next challenges?
I think the next challenges are more to spread the technology to other countries and that other countries will adopt the technology. When I look in the Netherlands, then the technology is quite mature. So it doesn't matter what is the type of application. So the well system and how to connect the heating and cooling to a building, that's all known. It's common practice. So it doesn't matter too much what type of building. But what I see that in other countries, the number is still limited. So I think that there's a need that other companies will start up the business and integrate it as one of the solutions they can offer to the customers locally. Because I see that there's a strong focus on closed loop, but there's hardly no attention for the open systems. While I still believe that it's still an interesting, and I see some legal constraints because in some countries it's quite hard to get a permission for abstraction and injection. It's not integrated in the building regulations. So if you build a building, then you get positive what do we say, awards that if you install a closed loop system, but for open systems, it's not so common. So there are the major challenges, I think.
And I have a second question to you, Bas. It's to ask also your view on this topic. You mentioned that you work with data centers, so to valorize the waste heat. We have seen and hear from some product developers in Europe that one issue is that they have a waste heat from data centers they inject at low temperature, at 30 degrees, which is hardly to be used after for district heating, for example. So do you see some issues, and what could be the solution to ask them maybe to have a waste heat at higher temperature, 60 to 70 degrees? What is your view on that?
I'd say that this question is coming up quite often because the idea is very interesting. I think when you can store the heat of the data center and then reuse it and feed on a district heating network, that's fine, qua concept. Then you still probably need to have a heat pump to increase the temperature level to the district heating network. The big challenge so far I see is that especially the data center would be quite sure that they can get rid of their heat. And so on a contractual base, there are the biggest challenges to arrange it. And sometimes, and also the location itself. So a data center should be quite close to a heat user. So in the Netherlands, we have crowded areas, and then the data center is often in city area, so that it's not so problem. When I have some discussions with consultancy in the US, they say they want to plan a data center in the middle of nowhere. So then you can store it, but it's quite hard to bring the heat and to a city to users who can really make use of the heat. So it's not always the technical challenges, it's sometimes more organizational challenges or to get a good proper business case because in fact low temperature heat has a relative low value and that makes it sometimes more complex.
No, you're perfectly right. But not a discussion for today, but probably if you're able to install a ATESS close to data centers, maybe you could think also providing some cooling to them with open loop.
That's what now they want to more to collect the cold during winter time, store it, that they create a more cold buffer, and then they especially want to cool down the peaks during the summertime because the peak load is now more expensive because due to all the net congestion problems and challenges. So if they can reduce the peak electricity consumption, that will really help them, and that's now a more commercially interesting strategy for data centers.
Thank you, Bas, for these remarks. By the way, as EGEC, we are collecting several data about data centers and how we can provide electricity 24/7, cooling, waste heat, valorization. A publication will come later this year, and probably a webinar, so all experts will be invited to contribute to this work to valorize geothermal energy for that. Michel, I have a question for you. So when can we expect drilling a production well in Geneva to feed in the district heating?
I hope, I guess you will not have to wait too much. It's planned for this year, actually. The first valorization doublet is planned for the end of this year, hopefully. It will not be such a deep well. It might be 1.3, 1.4 kilometer deep well. We expect a temperature of 50 degrees. And of course, even if we are working a lot on decreasing the temperature of the network, only a part of the energy will be valorized directly. So it means that we will need some heat pumps in order to valorize the energy we are expecting. But it makes sense because, as you saw on my slides, we are already developing some other cooler sources, water from the lake, sewage water, which are lower in temperature than the one I mentioned before. And we expect that we'll learn a lot from this first doublet, because this first doublet will be placed with the help of the 3D. We think that the probability of success might be quite high. We'll be drilling the Malm aquifer, the Mesozoic, but that's the uppermost part of this fractured and calcified limestones. And what we see on the features that we have on the 3D is that these fracture zones and these calcified zones are going deeper as well. So it will be a first valorization well, but it's still a kind of exploration, a way to go further, to learn more, and to go deeper for the next wells. So it's coming. We sent a tender months ago. We choose a drilling operator, and it's planned for the end of this year.
Okay, permitting is given, so you can be successful. Indeed, I think we need this successful development in Geneva and after a full replication all over Switzerland. Do we have a last remark from the different speakers today before I deliver the conclusion? You still have possibility to intervene. If not, I will give the conclusion. No, I don't see any remarks. So indeed, it's coming to the end of our webinar. I hope you enjoyed the webinar. We were more than 40 people in this EGEC webinar. Meet the members. So I thank you, Quentin, Sian, Niyazi, Oliver, Bas, and Michel. Really thank you for all this intervention. The webinar is recorded. It will be sent to all EGEC members. We have received already in the first trimester 2026 more than 10 applications to become a member of EGEC. So we will plan another meet the members probably before summer. As EGEC, we invite you also to some events up. So we will have our annual general meeting and a summer party 3rd of June in Brussels. On the 4th of June, we invite you for a policy summit to present notably the upcoming European Commission Geothermal Action Plan, which should be released on 19th of May. We will have a Geothermal District and Cooling Days in Dublin, 3rd of September, a Central and Eastern Europe Forum on Geothermal Energy in Bucharest 29 and 30th. Still other events have to be planned, not only the Geothermal Heat Pump Days, the Geothermal Innovation Days, but for the moment you can already mark your calendar with this event. It's the one organized by EGEC. We also help and support other events. Look at our newsletter, look at our roundup as a member to see all this information. Thanks again for all the interveners, the members, the attendees, and I wish you a good end of this Friday afternoon. See you. Bye-bye. See you soon.
Thank you.
Bye.
Thank you.
Thank you all. Bye.